We are going to discuss the deflection of beams. So there are a lot of ways in which we can solve for the deflection of beams. One method for that is the geometric method. So the geometric method relies heavily on figures. So in order for us to compute for the deflection, it is very important that we have or we can draw the figure or we can draw how deflection looks like. Kasi yun yung basis niya to solve for the deflection. Okay, let's talk about what is deflection. So, deflection is really a familiar term for us since this has already been discussed in our strength of material subject. So, to recall, deflection is the bending of the material after the application of load. So, say for example, sa figure natin, you see that there is a concentrated load acting at the center of the beam. So, of course, the beam will also be affected. So, at the mid-span, yung sa gitna ng beam, it's unsupported. Walay tukod dira, walay column dira. So, of course, the deflection or the bending is excessive. Mas maklaro na to or mas exaggerated ang bending at the mid-span since that is the most unsupported part or location of the beam. Unlike sa supports, dili kayo na to makita nga naa siya'y pagbaba or deformation, deflection sa tuang beam since at the supports, merong columns. Okay, so why is deflection important? So in design, it's not only enough that we can determine how many bars or paano natin i-reinforce ang ating structure. Hindi lang siya importante. Importante din ang pag-bend or deformation ng ating structure. Okay? Is it kanang allowable? Is it desirable? Kasi pag sabihin natin, for example, meron kang structure, meron kang frame. Oops. So, for example, meron tayong frame. So, straight line, frame yan. Okay, so, kita natin, okay naman siya. Meron siyang loads applied. Hindi naman siya nag-fail, meaning hindi siya na-collapse. So, feeling natin okay na. But, is the deflection desirable? Like, baka naman sobrang bend na ng beam or frame mo. Or hindi na siya mag-straight mo, na siya. 'Di ba? Maganyan na siya. So, is it desirable? So, it's not right. Although, kaya pa naman ng frame, kasi hindi pa naman siya nako-collapse, but the deflection or the bending is not desirable anymore. That's why, in design, sa structure, we also have to take note or consider the maximum allowable deflection. Okay? So, that is in our code. So, for a beam, the allowable lang na deflection or highest na pagbaba niya diri must equal to the total length divided by 360. So, say for example, we have 6 meters na beam, 'di ba? 6 meters na beam. So, ang allowable deflection lang ana or bending niya is of course 6 meters divided by 360. So, pila man ng 6 divide 360? So, that's equal to 0.1667 meter. So, convert to millimeter, so that's equivalent to 16.67. So, what I'm saying is, if you have a 6 meters na beam, ang allowable lang niya na bend dere, kung ang maximum bend is mag-occur sa gitna, ang maximum lang dapat na mag-occur dito is just 16.67. That's it. So, for this reason, building codes limit the maximum deflection of a beam to about 1 over 360th of its span. So there you go. Okay? So para sa geometric method, there are two famous na categories under this one, or two famous types under the geometric method. We have the method of double integration as well as the moment area method. So these two, I know you already have an idea for this one since this has already been tackled in our strength, but we can still, or we have to still recall it in theory of structures. Okay, so for double integration method, so it is based on the fact that the deflection or the curvature of the beam follows an equation. Okay, so say for example, we have this beam A, B, C, D, E. So, kung atuan na siyang A plus star sa XY plane, as what you've been seeing right now, okay, di plus star siya sa XY plane. So, with the applications of load, of course, we can predict that the deflection of the beam behaves like this, or the beam behaves like this. So, at here, di ba, dako siya og deflection, kay unsupported man na dira, up until here, and then total here. So, pag ganon. So, ang kani siya na curvature, di ba, this follows an equation, y, in terms of x. So, this is an equation described by x. So, if we look at a tiny element lang, for example, ito yung nag-bend na beam, and ito yung original niya na, na position, straight siya in the beginning, and then with the application of load, nag-curve siya. So, if we were just going to get one element lang, say B. Okay, so, ang iyahang distance from the x-axis, we call it the differential V. Okay, and then, of course, di ba, ang angled man na siya diri. So, pag-abot diri, ang angle niya is theta plus, of course, differential theta. So, if we are going to get the dv over dx is like a triangle, right? So, that's equivalent to theta, sine theta. So, dv over dx is sine theta. But, due to the fact that theta is very small, so mahitabo, sine theta is just equal to theta. Kasi maliit lang yung angle. So, yung sine theta, maging equal na lang yun sa theta. So, therefore, ang mahitabo, this is dv over dx equal to theta. Alright? And then, we all know that dx, diba, curvature, is equal to the radius rho. Rho is the radius of the curvature times the differential angle. Diba, arc length? Remember ninyo ang arc length? Arc length ni siya. Puntahin mo ni ang arc. Ni mo na ang radius, r. Theta. Nya s. So, diba, ang s, arc, is radius times theta. So, for this one, the arc or arc length dx is equal to the radius rho times the differential theta. Okay? So, therefore, you can say that 1 over rho is equal to d theta over dx, right? But, in the beginning, we established that theta is equal to dv over dx. So, substitute lang. So, finally, we can have this one. 1 over rho is equal to the, unsa man ni siya, diba this is familiar, this is the v double prime, right? Second derivative of v. So, from the flexure formula in which 1 over rho is equal to moment over EI, And then 1 over rho is the second derivative of v. So therefore, we can substitute it. So mahimong second derivative of v is equal to m over ei. And finally, we can say that ei times second derivative of v. And in this case, ang v natin is y. So ang v double prime is also y prime, y double prime. So masabi natin ei y double prime is equal to m. Ito, ei y double prime is equal to m. So if we integrate this equation, knowing that e and I are both constants, and y double prime, integrate man na siya, diba? Unsa integral, or unsay ka ng integration sa y double prime. Ibalik nimo siya, diba? Kanang first derivative, y prime. Balik nimo siya ba? And then, ang m, this is in terms of x. This is expressed in terms of x. So, of course, integrate na to na siya with respect to x, dx. Plus, constant. Kada mag-integrate ka, na-adjoy ma-generate na constant. So, sa first integrate na to, na-generate na constant. So, we call that C1. Okay? And this, guys, this is basically the slope equation. So, if we are asked about the slope of particular location in the beam, so we can use this one because this is the slope equation. What I'm saying is, balikan na to ang katong figure. 'Di ba? Mao man ni siya tong 'di ba mao man ni siya tong curvature sa beam. So at different location na ni mga theta dera, theta dera, theta dera, theta dera. Okay? So if we are concerned with the theta, kanipod na theta dera, tanan parts na ay mga theta. So if we are interested sa slope, then we can use the slope equation, which is ito. Okay? And then, if we integrate this further, integrate natin yan, ang mahitabo, ang ei, constant man na, so yung second integration is still ei. And then, ang y prime, kung integrate na to na siya, mahimo na siyang y. And then, ang mdx, kung integrate na to na siya, may mo na siyang mdx dx. And then, ang c na slope, c1, so magkaroon siya ng x, and then c2. Diba? Maduha na ang constant. Okay. Since sa ato ang equation, there is an involvement of constants, 'di ba? Sa slope equation na ay na involved na constant C1, and then sa deflection. Deflection is katong deformation equation. Naapoy na involved na equation, we have to get the values for that. So na-remember ninyo sa DE differential equation, 'di ba? Magkuan mo dito, mag-integrate, mag-derive, and then 'di ba naamay magmugna na mga constant. So para makuha nimo ang exact solution, mag-set kag mga boundary conditions. So mao pud ni diri sa double integration. By the way, this is also an application sa differential equation kanang sa beams. Okay, so para ma-get rid ta, mahawa na to ng mga constants, get rid of constants, then we have to set for the boundary condition. So, ani lang ang timanaan. So, at fixed support, kung asa dapit banda yung fixed support, wala yang siyang slope. Therefore, y prime is 0. Diba? So, for example, ito, cantilever beam. Diba? May load dyan. So, ang usual na pag-deflect ng ating fixed support is pag ganito. Right? Dito, parang hindi pa natin makita ang deflection hanggang dito. So, therefore, there is no slope here. Walang slope dyan. Kasi, essentially, parang straight line lang yan siya and then naging ganito. Alright? And then, at hinge or roller support or fix, even sa fix, no deflection also. Meaning, wala ni baba ang beam dere. But here, since this is unsupported, walang support, of course, na ay y dara, height of y. Okay? For example, ito. Yan. So, ang usual na behavior ng beam, if may concentrated load P dyan, of course, mag-smile yan siya. So, dito yung pinaka-grabe ang kanyang pagbaba. So, we call that Y. And then, around this point, wala siyang deflection. Kasi, both of the points are supported. Okay? So, yun yung ibig sabihin at hinge or roller support fixed, there's no deflection. Okay. Let's answer problems using double integration method. So the cantilever beam AB, so you see that AB of length L shown in the figure carries a uniformly distributed load of intensity WO, which includes the weight of the beam. So kasali na daw ang weight sa beam yan. Compute the maximum displacement of the beam if the beam is W12 by 35. So I know you're all familiar with that. This is a I-beam. I-beam. Diba? Anong W ang pangalan, ma'am niya? I ang shape. Karon sa mga steel, pansin ninyo, mga steel beams or column, I shape. But W ang tawag ana because pasabot ana wide ang flange. Kasi ito na part, this is the flange. So, mo na siyang W kasi wide ang flange. Anyway, ang inertia nito, moment of inertia, if we look it up at the kanagong steel manual, which is at the back of your book sa strength na ana siya, makita na to ang inertia sa shape, W shape. Okay? So, naaiduhan na kaklase, we have IX and IY. So, unsay kalahian sa IX ug IY? So, if ang atoang shape is nakapatong sa x-axis such as this one, this is IX. Ang IX ana is mo ni ang value. Pero kung ang shape nato is nakapatong sa Y, kibali murag ma-H na siya sa tong pananaw. Kung H ang iyang plastada, so kapatong siya sa Y, so therefore this is IY. Okay, so usually we use IX kasi the beam is stronger when it is panang nakapatong siya sa x-axis. Okay, anyway, basta yun yung mga properties. W12 by 35, this is a steel section with inertia equal to 285 inches to the fourth. So using length of the beam equal to 8 feet and the intensity of the load, WO, is equal to 400 pound-feet, and the elasticity, modulus of elasticity sa material mismo. Diba? If we can remember, the modulus of elasticity of steel in English system is 29 times 10 raised to 6 psi. Kung metric or SI, ano man ang elasticity ng steel? Remember, 200 gigapascal. Okay? So, these are the common values na usually nato makita. Okay. So, let's begin. Of course, ang maximum displacement of the cantilever beam occurs at the free end. Why? So, if we draw the deflection of the beam, so kaya nga sinasabi geometric method ito kasi dinodrawing natin yung mga deflection curve. So, of course, pag i-drawing yan, the maximum displacement or deflection occurs at the free end. Kasi at the free end naman, wala man siyang support dyan. So, free to bend siya. Okay, so, we know earlier sa itong derivation that EI y double prime is M, moment equation. Okay, so ito yung figure natin. So we have to get the moment equation for this beam. So how to get for the moment equation? So we have to cut the beam. So we have to cut it here. Okay, so kung i-cut na to ning beam, considering the left side, di ba pag i-cut diri, pwede man na to i-consider ang left ug ang right. Okay, ano lang, kanang recall lang sa pag-cut sa beam. So, mo yung original beam. Tama? So, gikat na to na siya. So, pwede ta mo consider left or right. So, kung consider left, so ito yung itsura niya. Kibali ang shear pababa, ang moment pa-counter. Kung consider left. Kung consider right, so mo ni ang right. Ang shear pasaka, ang moment pa-clockwise. Okay, so opposite ang direction. So, ikaw na bahala. Insay mo i-consider left ba or right. So, mas maayo i-consider na to ang left. So, kung i-consider ang left, morning itsura sa beam, correct? So, of course, we do not know where nato na siya gikat. So, let's just call it X, diba? At any interval lang man, dapit. So, wala kabalo. So, let's just call it X. Karon, if we sum up moment at cut, di ba nga na mag-moment man ta sa cut, kay kailangan man natog moment equation, kay EI double prime is moment equation man, so makuha na to ang moment equation using sum up moment. So, mag-moment ta about sa cut, say clockwise is positive. So, if clockwise is positive, negative, ang WO about the cut is counter man na, so negative. Negative WO times x over 2 minus m equal to 0. So, m is negative WO x squared over 2. Okay? So, therefore, the EIY double prime is m man. So, therefore, EIY double prime is negative WO x squared over 2. So, integrate both sides of the equation. Integrate natin to. So, of course, ang EI constant yan. So, still EI. Ang Y double prime, integrate Y prime lang. And then ito, integrate negative WO x cube. Diba? 2 plus 1 cube. 2 times 3 plus C1. Of course, gi-integrate man nimo. So, naay na-introduce na constant, which we call C1. So, therefore, this is our slope equation. So, if it asks about slope, then we can use this equation. Pero, dili man slope ang pangutana. Ang pangutana man is deflection. So, we have to integrate this one further. So, kung integrate na to ni siya further, pana ang slope equation, integrate na pud nato gusab. Okay, so therefore, we can have EI, ang y prime, mahimo na lang y, is equal to negative WO x 3 plus 1, 4 over 2 times 3 times 4. Power formula lang ang gi-follow ani. Plus C1x, ang C1 magka-x na siya, plus C2. So this one is what we call the deflection equation. Now, as you can see, we have the introduction sa mga constants, which are C1 and C2. So we have to find a way para mag-get rid na to na siya, mawala na siya. So use the boundary conditions. So, for slope equation, ito yung slope equation. Ano yung ma-apply natin? Remember na ganito yung itsura ng beam. Ito yung itsura ng beam, right? Fix dito. Okay? So, pag-fix gani, walay slope. So, asa man na banda ang fixed support? Look at the original figure. Ang original figure is, ang fix is na diri. So, when x ang distance ha, so when x is equal to L, there is no slope, right? Walay slope when x is equal to the length kay at x equal to the length, naaman na to makita ang fixed support. And we said earlier that at fixed support, there is no slope. Okay? That's why, dito, sinabi natin na at x equal to length, y prime is equal to 0. Okay? So, substituting, kung y prime pala is 0, so ma-0 na siya. So, negative WOL cube over 2 times 3 plus C1. So, therefore, if we solve for C1, in terms of WOL, so C1 is equal to WOL cube over 6. Okay, so nakita na nato ang value sa C1. Now, let's move on to find or let's get the final slope equation. So, ang final slope equation, instead na lagyan mo yan ng C1, so ilagay mo na ang equivalent ng C1. Okay, so here is our final slope equation. Now, let's go ahead and get the value of C2. And then, asa man nato makitaan ang C2, nag-appear siya for the deflection equation. Nakita nato na siya dito. Therefore, okay, therefore, gamitin natin yung deflection equation. So, again, ito yung figure niya ha. So, when x is equal to L, support ang makita. And at support, there is no deflection. So, when x is L, deflection y is 0. And then, from earlier, di ba C1 is WOL cube over 6. So, substitutan nato ni dire. So, we can have EI times 0 is equal to negative WO times L raised to the 4th over 2 times 3 times 4 plus C1. C1 is siya. And then, ang X na to, alisdan makag W plus C2. So, therefore, solve for C2, we can have negative WO L to the 4th over 8. So, ibalik na to na siya sa EIY. So, the final deflection equation is ito. Okay? Yan na ang final deflection equation without the presence or appearance of C1 and C2. Okay, now let's go back to the main question. What is the maximum displacement of the beam? So, as what I've said earlier, ito yung figure natin. And then, ito yung deflection niya nga curve. So, the maximum displacement occurs at the free end. And when it is at the free end, the x there is 0. Kasi dyan man nag-start yung x. So, x there is 0. Okay? So, you get now the idea? Balikan natin yung deflection equation. And then, we have to substitute x equal to 0. Okay? So that we can solve for EIY. So, substituting, we can have y, or the displacement, equal to negative WOL raised to the 4th over 8EI. So, the negative here, it only kanang shows na pababa ang y. Kasi, diba, nibaba ang curve. The curve is below the beam, the original beam. So, morning minus, nibaba ang beam. Okay? So, that's equivalent to negative WOL raised to the 4th over 8EI. Okay? And then, naman tayo value sa L, sa E, elasticity, as well as the inertia. So, substitute lang ta. Okay? Substitute lang ta. So, we have to be we have to be cautious sa tuang units. Kasi this one is displacement, right? So, it is expected that the resulting unit is in terms of length, whether in millimeters, meter, feet, or inches. Basta unit of length kasi maximum displacement man. So, substitute na to, WO is 400 pound per feet. ang length is 8 feet. So, raised to the fourth. So, ang gibuhat is convert pa na siya. Over 8. 8 is the constant na siya daan. Multiplied by E, which is 29 times 10 raised to 6. PSI man yun. So, pound per square inches. And then, yung I is 285 inches to the fourth. So, cancel, sama cancel. So, what's left is the unit of inch. So, negative 0.0428 inch or 0.0428 na pababa ang arrow to signify that the bending or the displacement is pababa. Okay? So, if maka-encounter mo na ingon ani ang figure, okay, kung maka-encounter mo inani ang figure and then solve for the deflection at the free end, so pwede na ni siya na formula if you can recall. Okay, if dili pud ma-recall, pwede rin po balikan. So, double integration, pwede. Okay, so, kani siya, establish na pag inani ang figure, kani ang answer for the maximum deflection or displacement. Okay, so, that's it for our first example. Now, let's go to our second example. So this one, the simply supported beam show carries a load of 20 kilonewton per meter across its span of 5 meters, including the beam weight. So kasali na daw yung 20 kilonewton per meter sa beam weight. So elasticity is 200 gigapascal. So first, compute the following. Slope at support A. So ano daw yung slope at support A? Next is the maximum deflection of the beam. Next is maximum flexural stress of the beam. So, kay nag-ask man siya about flexural stress, the problem has to provide for the inertia, right? Just like the previous one, na inertia, but wala may inertia dira, nagihatag yun na diretsyo. Pero, nakita nato nga naa may figure or cross-section sa beam. Masolve na tong inertia na. Okay, first muna, slope at support E. So, what we do first, of course, we have to get the reaction of the beam. So, what is the reaction of the beam? So, ano lang man na siya, 20 kilonewton per meter across the span. So, di ba, kanang fully covered. So, if the supports are from end to end, so tungaan lang na nila. Unsa man ang total load? Ang total load is 20 times 5. So, that is 100 kN. So, kada edge and edge, tag 50-50. So, that's no-brainer. Dali ra kayo makuha ang reaction. Now, next na pabuhaton is we have to solve for the moment of inertia. So, 'di ba? If you can remember, ito yung kanyang section. The width is 150, the height is 250, so that is only a rectangle. So how do we get the moment of inertia sa rectangle na beam? So BH cubed over 12. So substitute, we have the moment of inertia of the beam equal to 195.3125 times 10 raised to 6 millimeters to the fourth. Okay? Now, 'di ba? Remember na kailangan nato ang EI, elasticity times inertia. Kay lagi EI y double prime is moment equation. So need na to ang EI. So might as well paon na lang dato daan ang EI. Kibali i-times na to ang elasticity sa inertia. So ang elasticity na given 200 gigapascal. So 200 gigapascal, that's equivalent to 1 times 10 raised to 6 kilopascal. Okay ha? 1 times 1 times 10 raised to 6 kilopascal is 1 gigapascal. So this is kilopascal, correct? So over 1 gigapascal. So ilang ni siya. Okay? Ilang na siya. And then ang I is the inertia. So ang inertia na solve naman, so morning inertia I. Okay? So, ato lang na siyang i-convert. Ang ato ang goal is mahimo siyang kilonewton meter square. Dapat ang resulting unit niya is kilonewton square meter or meter square. Okay? So, ang EI in kilonewton meter square, that's 39,062.5. Okay na. What's next? O, kuha na nato tong EI y double prime equal to M. So, EI pa lang ato ang gitrabaho ganina. Karon ang trabaho nato is the moment equation. So, saan man ang moment equation? Imuhang pikason ang beam or imo siyang ikat. So, nara na sa imo if we consider left or consider right. So, for this one, gikat na to ang beam but we consider left. Okay? So, again, we do not know where exactly ang cut. So, let's just call the distance as x. And this is the notation sa mga values like the shear and moment pag consider left. Okay? So, kay moment equation man ato ang need, so mag-sum up moment ta. Asa pod? Sa cut. Moment ta sa cut, where clockwise is positive. So, if mag-moment sa cut, 50 times iyang moment arm na x minus the total load, 20 times x, and then the resultant to the cut. Ang resultant is x over 2. Minus m equation equal to 0. Solve for m. We have m equal to 50x minus 10x squared. Okay? So, yun. Now, remember that EIY double prime is 50x minus 10x squared. Kasi diba, EIY double prime is m. So, substitute lang ang m diri. So, mo na ni ang result niya. Okay, so if we integrate it for the first time, so what results is EIY prime is equal to 50, tapos ang x, power formula, 2 over 2, x squared over 2, minus 10 times x cubed over 3 plus C1. So, notice that there is already an addition of constant, which is C1. Okay, and then if we integrate it further pa din, so we can have EIY equal to 50 times x cubed over 2 times 3 minus 10x to the 4th over 3 times 4 plus C1x plus C2. So, naanay involvement or appearance ni C2 for the deflection equation. This is deflection equation. Okay? Now, next step is we have to get rid of the constants. So remember that this is our figure. Okay, this is our figure, right? So what are the things that we can say about this one? So at supports, there is no displacement or deflection. At supports, diri. So sabihin natin, when x is 0, at the beginning talaga, no displacement, therefore y is 0. So, balikan natin yung deflection equation. Substitute lang natin. So, if y is 0, so makancel ito. If x is 0, makancel yan, makancel yan, cancel yan. So, C2 is just 0. Okay? Next. How about when x is 5? Ganong when x is 5? Kasi ang total length nito is 5. So, when x is equal to the total length, which is also equal to 5, then, okay, substitute again sa deflection equation kay y man na imong gigamit. Dili ka mag-substitute dito sa slope kay y prime man to dito. Dito ka mag-substitute sa naay y kay y man ni. So, balikan na pod nato. Pwede na siya. Pwede na to balikan na pod ang deflection equation. This time around, when y is 0, x is 5. Or when x is 5, y is 0. So, ang x, substitutan og 5. Ang y, substitutan og 0. So, what happens now is, of course, kung substitutan og 0 ang y, so wala na siya. And then, what's left is C1. So, C1, solving the equation, we get negative 625 over 6. Okay, so go back again. Sa slope equation, may C1 dito. So, Sa C1 equation, substitute lang negative 625/6. So, mana na ang final na slope equation. So, ang pangutan naman, what is the slope at support A? Diba? Sa first question, what is the slope at support A? So, that is essentially when x is 0. Kasi ani man ang figure. So, kung naa siya sa beginning, x is 0 na dira. So, substitute lang when x is 0. So, tanaw na to ang units. So, ang EI nato is in terms of kilonewton meter squared. Okay? So, when solve for y prime or slope, so ma-zero man ni. So, nabilin negative 625/6 over EI. Okay? So, makancel out ang unit. So, if makancel out ang unit, therefore, kuan kanang radians. So, ang ma-result, negative 1/375 radians. So, convert it into degrees. So, we get this one. Okay? Alright. By the way, guys, nakalikot kong ingon, pag EI, Y, double prime equal to M, ang unit ani is kilonewton meter. Why? Kasi moment, di ba? Pag moment, that's distance time or force times distance ang moment. So, ang unit ana is kn meter. Pag EI, Y prime, kana siya, ang unit ani, kilonewton meter squared. Diba? Gi-integrate man nimo. So, madungagan ang meter. Kung EI, Y na lang, so that becomes kn meters cube. So, maoni guys, since slope equation lang man atong gigamit, so ang resulting unit ana is kilonewton meter squared. So, mao lang kilonewton meter squared ni. And then, ang EI is also kilonewton meter squared. So, mo na mag-cancel out ang units. Mabili na lang is unitless or radian kasi slope man. So, kung gusto na to, dako-dako ang answer, so i-convert na to nag-degrees. So, we have negative 0.1528 degrees. So, negative, it means clockwise ang rotation. Kibalin, ani. Mo ni ang beam, mo ni ang bending. Okay? So, diri man ang A. So, mo man ang original na position sa beam. Unya, ni-bend naman siya. So, ni-rotate siya. So, ang rotation is clockwise. So, this is theta. So, theta is clockwise, diba? Ang rotation diri is clockwise. So, mo nang negative. Okay? Next. The next question is, what is the next question. Makakuan. What is the maximum deflection of the beam? So, what is the maximum deflection daw? Okay, so as you can see, this is just a simply supported, uniformly distributed beam. Okay? So, kung maximum deflection ang hanap natin, then, what can we say? Asa di ay mag-occur ang maximum deflection? Diba? Mo man yung figure, guys. Asa di ay mag-occur ang maximum deflection? Of course, sa tunga. Kasi sa tunga, wala yun ay kasuporta-suporta dira. Unlike kaning closer sa support. So, sa tunga man ang pinakalayo sa support. So, siya ang maximum. Yung unsa man iyang location when x is L over 2. Okay? So, the deflection equation, balik ta. And then, patong ano na gyud ha, wala na C1 o C2 na tagaan nag-value ang C1 o C2. So, mo ni ang deflection equation. So, substitute when x is L over 2. So, the L is 5 man. Ang tunga is 2.5. Midspan man, midspan. So, x is 2.5. So, substitute ha. So, solve for y. EI man ni EI. By the way, pag EIY, Ang unit ana is kn cubic meter. So, this is kn cubic meter. Okay? Solve for y. Anong naitabo meter na lang ni? Okay, di ba? Y is equal to kn. Kani nga term. This is kn per cubic meter, kn cubic meter. Yang ang ei baya kay kn square meter. So, cancel kn, meter na lang nabilin. So, gamay man kayo ng meter. So, pwede na to na siya i-convert into millimeters. So, ang equivalent ani is negative 4.17 millimeters. So, the negative signifies na pababa. So, 4.17 millimeters. That's our final answer. Okay, and then, what is the maximum flexural stress of the beam? So, pag beam gani, unsa ang stress? MC over I. Don't forget. Or my over I. So, ang M is the maximum moment. Unsa ang maximum moment kung ingon ani ang ato ang loading? Diba ang moment diagram ani kay nani? So, sa tunga ang maximum moment. So, dili na need na i-drawing pa. Timan-an. Kay gamit kaayo. Maximum moment sa midspan, WL squared over 8 lang. Okay, para automatic na ka mag-substitute. W is 20, L is 5 over 8. So, 62.5 ang maximum moment. Ang Y is pirmi na ko mapindot ang end. Wala mag sa keyboard. Okay, wake up. Okay, diri na ta sa Y. So, ang Y, di ba, is the distance from the neutral axis to the top or bottom. Neutral axis kay nasa tunga niya. 250 maning total height. So, Y is half sa 250 lang. Okay? So, therefore, ang Y diriha is katong distance, dili tong deflection. So, pwede ra pod MC over I para dili kayo libog. Anyway, basta mo na ang definition sa Y diri. So, substitute moment is 62.5 kilonewton meter. So, convert that into Newton mm. Okay, that's why the resulting answer FB, flexural stress of the beam, is equal to 24 megapascal. Okay, let's move on to double integration method using bracket functions. Okay, so sometimes the structure or the loading is not limited only sa one span. So sometimes daghan siya. For example, this one. Okay, so dili continuous ang load. So from this interval to this interval, wala siya load, and then naa na po'y load, wala siya load, na po'y load. So, if inani gani ang ato ang figure, dili lang siya simple lang ba na isa lang kabuok. For example, kani, continuous man ni siya, diba? Isa lang kabuok. Pag dili gani siya ingon ani, naani na siya dagway, then it's time na to use the bracket function. Pero still, double integration method gihapon. Okay, so how do we do this? So, kung inato atong figure, draw ko ulit. Ito yung figure natin. So, merong concentrated dyan and then uniformly dyan. So, if ito yung figure natin, we have to cut this one into 3 segments. Okay, so ang pag-cut ani, first, second, and then third. Just like what you do good if you draw the shear and moment diagram using shear and moment equation, di ba? Ginakat man nato ang beam. So, mapod itong buhaton diri sa double integration method using bracket function. So, as you can see, at the left of section 1, ito yung makita natin, di ba? Shear is pababa, moment is counterclockwise. So, pag section 2 naman ang i-consider, tapos left ang tanawon, so maupod ni ang makita. And then, section 3 na pod ang tanawon, cut, and then left ang i-consider, so mao ni ang makita. Okay, so, mora lang gihapon ta, nag-draw og shear and moment, or naghimo og shear and moment equation. Cut lang sa beam. So, as you can see, naana siya mga bracket functions. So, mo ni ang iyang mga bracket functions. Oops. Okay, so let's start. So, section 1, when x is greater than 0 but less than 2, di ba kaning first part? X is greater than 0 but less than 2. Unsa man ang moment equation ani, sum up moment about the cut. If we sum up moment about the cut, the moment equation is 480x, di ba? Remember, sa moment equation method. And then, when x is greater than 2, pag unsa gani ang diri amo, na pwede mo ibutang diri, when x is greater than 2 but less than 3, unsa ang moment equation? Again, mag-moment ka sa cut. Unsaan pag-moment sa cut? Say clockwise positive. Unsa man ang clockwise moment about sa cut? 480 times moment arm na x minus 500 times, unsa man ang moment arm, padulong sa cut, 500 times, the moment arm is x minus 2. Okay? Muna siya ang moment equation, considering the second section. And then, when x is greater than 3, but less than 5 until sa end, so if mag-moment ka sa cut, say clockwise is positive, so 480x, moment sa cut ha, 480x minus kaning 500, unsa yung moment arm about sa cut? X maning total distance, x minus 2. Okay? Minus kaning 450 na uniformly distributed. 450 times x minus 3 times x minus 3 over 2. Basin maglibog mo ba? Moment ko diri sa cut ha. Look at this. 480x minus 500. Isa yung moment arm about sa cut. X minus 2 minus kaning 450. 450. Unsa man na ang iyahang length diri? X minus 3. O total load pa lang na. Ang centroid niya padulong sa cut, x minus 3 over 2. So, mao ni. Okay? I-combine lang na siya. So, importante na sa tuang double integration method. So, ang ato ang i-adapt para sa ato ang moment equation is katong makuha na tanan, which is ito. Kanina tong i-adapt. Pinakalas. Kay kuha man na tanan. 480x minus 500 times x minus 2 minus 450 over 2 times x minus 3 squared. Newton meter ang unit kasi moment pa man ni. Okay. Let's apply the Macaulay bracket function. So, ang ibig sabihin lang sa Macaulay bracket function is that, kung ang bracket gani, 0 ang answer or negative ang answer sulod sa bracket, we will not consider that term anymore. For example, ito. When x is 2 na lang, 2. Or 1, when x is 1, Kung mag-substitute ta when x is 1, diri na moment equation. So, ang mahitabo, tanawon sa nato ang bracket. So, kani, di ba, 1 man, 1 minus 2. So, sa makulay bracket function, pag negative gani ang answer sa bracket, so, dili na siya i-consider. So, 0. Considered 0 na siya. Basta negative ang answer sa bracket. Kanipod, di ba, 1 minus 3, negative. So, dili na po na siya i-consider. So, may tabo, when x is equal to 1, kanilang na moment equation ang ma-activate. Which is tama din naman. Kasi, di ba, if we look back sa segment, when x is 1, diri man na siya banda. Diri lang man na siya banda. So, kay dira lang na banda, when x is 1, 1 meter, kanilang na moment equation ang dapat na ma-apply or ma-activate. So, tama arapod na pag negative gani ang answer sa bracket, ayaw na siya apila sa pag-solve for moment. Okay, nakuha? Sige. So, malang itong ibig sabihin na itong daghan kay blah blah blah, ako na lang i-summarize. Okay, let's answer this example. The simply supported beam ABC in figure A carries a concentrated load of 300 Newton as shown. Okay, so dili na ni siya matabang og katong double integration method lang na normal. So kailangan na ni siya og bracket function kasi i-cut man ni nato into two section. Katong sa previous nato na examples, katong uniformly distributed good, piling inani lang. So, kaisa lang man ta mag-cut ana. So, kato lang normal na double integration method. However, sa tuang example karon, paduha na ta mag-cut, di ba? Paduha na. So, mao ning bracket functions na ta. So, take note that the EI is 20.48 times 10 raised to 3 Newton meter squared. Okay. So, diretso na, nanay reaction. So, kabalo naman magkuha sa reaction. So, ang reaction at A, 100 Newton. Reaction at C, 200 Newton. Okay. So, ang pangutana diri, determine the deflection at 1 meter from the leftmost support. So, when we say 1 meter from the leftmost support, that is just x equal to 1. And then also, determine the y max. So, asa man ang y max ani guys? So, mama ni ang drawing sa deflection, no? So, of course, kung asa gi-apply ang concentrated load, dito ang y max. So, therefore, x is 2 ana. Okay? When x is 2, dira makita ang y max. Okay. So, let's apply the double integration formula. EI y double prime is equal to moment equation. So, cut ano. So, sa first cut nato, kani ang atong na-generate. By the way, ang pangutana di ay sa first, determine the deflection at 1 meter from the leftmost support. So, x is equal to 1. So, diri lang na siya kutob. So, sa first cut lang na siya. Unsa man ang moment equation sa first cut? Kana, di ba? Sum up moment ani. Sige, dili man makita ang figure. Dili na lang ako magsulat. Sum up moment ani. Moment about sa cut equal to 0. Say clockwise positive. So, 100 times x minus 300. Unsa moment arm niya about the cut here? Times x minus 2 minus m equal to 0. So, m is 100x minus 300 times x minus 2. Okay ha, mo ni ang moment equation. So, mao ni siya, 100x minus 300 times x minus 2. So, substitute lang, EIY double prime equal to moment equation. So, integrating EIY prime is equal to 100x squared over 2 minus 300. So, ang pag-integrate lang ani is power formula lang. So, kaning x minus 2, di ba? 1 man na exponent dara. So, 1 plus 1, 2 over 2. Power formula lang ha, plus C1. So, nanay C1. And then, integrate further. So, mahimo na siyang EIY is equal to 100 times x cubed over 2 times 3 minus 300 times x minus 2 raised to 3 over 2 times 3 plus C1x plus C2. Okay, mo na lang nahitabo. So, ang pangutana, what is the constant muna? Constant muna, getting rid of constant. So, if we get rid of constants, say at x is equal to 0, again, ito yung figure, di ba? And then, nadiri ang load. So, when x is 0, y is also 0. Kasi sa beginning man. So, substitute y is 0, x is 0. So, look at this one, guys. Kani, 0 man ni. So, of course, cancelled out. So, 0 minus 2. So, 0 pud na siya. And then, C1 times 0 plus C2. So, C2 is 0. Kani, negative. Not considered anymore because the answer of the bracket is negative. Dili 0. Negative. Basta ang answer is negative, not considered na anymore. So, 0 minus 2. So, 0 na siya. Karon, when x is 3, di ba ang total length is 3, y is also 0. Kaya nga naman, marag, ano yata ni diri 2 meters, nya 1 meter. So, when x is 3, so y is also 0. So, mo ni. So, substitute. Okay, so therefore, makuha na to ang C1, na i-value ang C1, negative 400 over 3. Okay? And then, go back sa deflection equation, 100 times x cubed over 2 times 3. Okay, substitute lang. Muna na ang deflection equation. So, first question, what is the deflection when x is 1? So, substitute lang when x is 1. Okay, so unsa nyo napansin? Wala na nilabot. Bakit? Kasi, the answer sa bracket, 1 minus 2 is negative. So, wala na siya labot. Mao nang, nabili na lang, kana o kana. And then, solve for y. So, we have negative 0.0057 meter or 5.7 millimeters pababa. So, the next question, what is the what is the maximum deflection? So, ang maximum deflection is when x is 2. Kasi diri man tong load. 2 meters man niya, 1 meter na siya. So, y max is when x is 2. So, substitute lang. Then, solve for y. So, y is negative 0.00651 meter or 6.51 millimeters pababa. Okay? Okay, so that's it. That's how we solve for the deflection. Okay, next example. Find the maximum displacement of the cantilever beam given that EI is equal to 30,000 kilonewton meter squared. So, ito yung figure, guys, ha? So, ano daw ang maximum displacement of the cantilever beam? Okay, asa man ang maximum displacement mag-occur? Of course, sa free end. Diba? So, first, let's solve muna for the reactions. So, mabili naman nung magkuha sa reaction. So, ang reaction lang ana, diri vertical is 40 and then naay clockwise diri na to 40 kilonewton meter. And then, after sa reaction, ikat na to ang beam. Right? Ikat na to ni. Dili lang ni siya kaisa ikat. Nganong dili man pwede kaisa ikat, dili man na siya continuous dira o. Bali, ano man siya, putol na load, putol na distributed. So, kaduha ta mag-cut ana, supposedly. Okay? Pero sa bracket function, dito na lang ka mag-cut sa pinakalasan para harus na tanan. Pareha ani, balik ta sa previous na example. So, ngano ni siya? Ngano ni siya na moment equation? 100x minus 300 times x minus 2. Kasi 'di ba yung original na figure kanina is inani 300 yata ni dere 100 kani kay 200. So dito lang ta nag-cut sa far end sa pinaka-last gyud. So mo nang 100x minus 300 times x minus 2. Iha para haros na tanan. So mao pod na atong buhaton dire haros na tanan dira ata mag-cut. Okay? But the problem is at this location guys, putol ang load. Kibali ba, nagsugod ta og uniformly distributed, kaso sa portion kung asa ta mag-cut, putol siya. Diba? Supposedly dapat naa na siya dira. Okay ra pod, balag wala na lang na siya dira. Okay? Basta, kung mudungag po ka sa ilalom para murag wala lang. Balancing ba, counteracting. Kay ado manggod kanang violation siya na mag-cut ta sa portion nga putol. Kay kani siya, this is kanang understood na continuous ang loading. Kaso dili man siya continuous ang loading. Okay ha? Nagsugod naman good og uniformly distributed. Supposedly dapat padayon na siya dira. Pwede siya ipadayon until sa cut. Kaso magdungag pug ka diri para fair, para murag wala lang ni siya. Kasi kung kana lang imong ibutang niya, dili ka magbungag sa ilalom, imo ang gi-alter ang given, dili na mao ang given. So para murag wala lang daw effect gihapon, so mag-counteract ka sa ilalom. Kaya inani ang iyang dagway. Inani iyang dagway guys, tanawa, 'di ba? Nagdungag ko for the sake lang na continuous ang pag-cut. But of course, nagdungag po ta sa ilalom para murag wala lang siya. Kasi kung dili ta magbutang sa ilalom, nagbuot-buot ta og change sa given. Okay? So, inana na siya. Karon sa inani na figure, mag-moment ta about sa cut. So, sa moment about sa cut, say, count clockwise positive. So, negative 10. Ang length is x times iyang moment arm x over 2. And then, kaning gamay. Kani lang. Plus na siya, kay clockwise man na siya about the cut. Yang length is x minus 4. Ang iyahang distance from the centroid to the cut is x minus 4 over 2. Okay? So, nanak tayo moment equation. So, wala na siyang tarong og sulat. Mawala ni ang iyang equivalent. Okay, so EIY double prime is equal to M. So, EIY double prime is equal to negative 5x squared plus 5 times x minus 4 squared. 5 times x minus 4 squared. So, muna itong moment equation. Okay? So, integrate. Mahimo na ning EIY prime. So, integrate lang ni using the power formula. Power formula lang ang pattern ha. So, mahimo ng negative 5x cubed over 3 plus 5 times x minus 4 raised to 3 over 3 plus c1. And then integrate further. EIY is equal to negative 5x to the 4th over 3 times 4 plus 5 times x minus 4 raised to 4th over 3 times 4 plus c1x plus c2. So, na natin mga constant. So, of course, we have to get rid of the constants. Kuhaon na to na siya. So, itong condition, isa may pwede ma-apply na condition ani. Nani man na tong figure. Na diri and then fixed ni. So, 4 meters, 4 meters. So, consider left man ta, guys. So, when x is 8, there is also no slope. Y prime is 0. Ano ni siya? So, when x is 8, y prime is 0. So, substitute lang. So, C1 therefore is 2 to 40 over 3. Right? And then, when x is 8 also, there is no displacement. Y is also 0. Okay, so substitute. We can have C2 as negative 13120 over 3. Okay? And then, therefore, the deflection equation, balik ta sa deflection equation, na substitute na natog C1 ug C2. So, mo ni ang final na equation. EIY is equal to negative 5x to the 4th over 3 times 4 plus 5 times x minus 4 over 3 times 4. And then C1 ni siya ha, and then C2 po ni siya. Okay na? So, ang pangutana, what is the maximum displacement? Oops. Okay, the maximum displacement is when x is equal to 0. Why? Kasi again, ito yung figure. Diba? So, kung drawingan na og deflection, diri gid ang maximum. So, the maximum occurs at the free end. So, when x is 0 na siya. So, substitute. Therefore, we can have y equal to 0.1458 meters or 145.8 millimeters. Okay ha? Again, ang EI, kilonewton cubic meter. Kani is kilonewton. Ang EI DI is kilonewton meter squared lang. Kani, cubic meter. So, meter na lang mabilin. Cancel ang kilonewton. Cancel ni, meter na lang mabilin. Morning, meter ni. So, kay gamay man, decimal. So, pwede na to na siya millimeters. Okay? Okay. Next. Pwede pod na to i-cut from right to left. Kibali, kung diri ta mag-cut, pwede ta, kung pwede po ta na consider right na lang, pero diri na ta banda mag-cut. Pwede sad na siya, kani. Pwede ana. From right to left. Right to left ha, far end man. Isa man ang far end sa right. Kani. Pwede na siya. So, dili na ta magdungag kasi at the cut, portion sa cut, naa pa man gihapon ang uniformly distributed. So, inani ang dagway kibali. Ani o. Na. So, kay consider right naman ta ani na part. Of course, ang shear is pasaka. Ang moment is pa-clockwise. Okay? Then, naa diri to 40. And then, naa 40 diri. So, ang x is gikan na sa fix. Kay consider right naman ta. Bali naman. Kani kay 4 meters. So, sum up moment about the cut. So, 40 where counterclockwise positive na ni. So, 40x, diba, about sa cut, minus 10 man ni. 10 times x minus 4. Kani nga distance, x minus 4 na siya. X minus 4 squared over 2. And then, ang 240, kay clockwise man na siya, so minus. Kay, ang lingon man dali, counterclockwise positive. Okay, therefore, kung ato ang i-simplify, the moment is equal to 40x minus 5 times x minus 4 squared minus 240. So, substitute na sa EIY double prime equal to M. Okay, so EIY double prime, moment equation, i-integrate na to, or formula lang. So, mag-appear na ang C1, then integrate further, mag-appear na ang C2. So, sa sunod, after mag-appear ang C1 o C2, we have to get rid of them, or we have to apply the boundary conditions para mawala ang C1 o C2, magka-number na siya dara. Okay, so unsa man atong maingon? At x is 0, y prime is 0. So nganong when x is 0, y prime is 0 na pod? Kasi 'di ba, ang ato ang pagkat is consider right. Consider right man ta. So ang x nagsugod sa fix. 'Di ba? So when x is 0 diri, consider right atong gibuhat. Consider right man ta. So ang x nag-start sa fix. So when x is 0, y prime is also 0. So, substitute lang, we get C1 equal to 0. Karon, when x is also 0, the support is also 0. Y displacement is also 0. So, substitute again. So, we have C2 as 0. C1, C2 is 0. Now, for our deflection equation, ito na. Okay? And then, substitute lang C1 equal to 0 ug C2 equal to 0. Karon, maximum displacement man. Again, ingon ani atong figure. Ang x nato nag-start dere. So, x is 8. Ang maximum displacement when x is 8. So, substitute when x is 8. Still, we have answer y equal to 0.1458. Same answer kanina. Negative din siya kay pababa. Okay? So, ana lang. So, pwede ra pod consider left or right. Pero mas maayo, left na lang yun para uniform. Para pud kay ka maglibog. Okay, next. Kanina pod na type of example. So, naanay couple ha. Determine the equation of the elastic curve for the overhanging beam. So, mo ni ang iyahang elastic curve. Baba, ana na pod, and then ana. Okay, elastic curve, deflection curve. Calculate the value of EIY midway between the supports. So, unsa daw ang EIY midway between the supports? Midway, when we say midway between the supports, mid daw sa support. Unsa daw ang total distance between the supports? 3 plus 3 plus 3, 9. So, unsa ang EIY at x is equal to 9 divide 2, 4.5. So, substitute lang na to when x is 4.5. Kuha na to ang EIY. So, EIY lang ang pangutana guys, kaya wala man gid siya naghatag og exact value sa EI. Wala siya naghatag, so as is lang nato na EIY. Okay? So, first always is to compute for the reaction. I know you are already familiar with the reaction. So, mo nang reaction diri kay pababa na 300, diri pasaka na 2,100. Okay. Next step, after the reaction, i-cut na to sa free end, far end. Kung kung left to right ta atong pagtan-aw, left to right, ang far end na to is dito. So, dili ta mag-cut. Okay? So, kung i-cut na to na, mo ni ang itsura. Kani, mo ni itsura pag i-cut sa far end. So, kay moment equation man atong kailangan, so mag-moment ta about sa cut para makuha ang moment equation. Okay, so ani ha, the moment equation, clockwise positive. So, ang 300, pababa man na siya, so negative 300. Moment arm about sa cut, x. And then, ang 2,700 Newton meter na couple, this is clockwise. So, positive na siya. Kay clockwise, positive man ni na equation. And then, ang kaning 300 counter man ni siya about sa cut. So, minus. Sa man ni length ani. Kung x ang total, so x minus 6 squared over 2. And then, ang 2,100 about sa cut, clockwise man na siya, so positive. Moment arm about sa cut, x minus 9. Okay ha? Karon, substitute na nato sa EIY double prime equal to M. Okay, copy lang. Negative 300x. Okay, kaning 2,700 kay couple man ni siya para continuous ang atong function, multiplyan nato na siya moment arm. Unsa ang moment arm ni 27 about the cut? So may distance gikan diri about the cut, x minus 3, diba? Kana x minus 3 na siya. Karon mga tana ta, ma'am, couple naman na, force times distance, moment na daan, nganong times ang pag moment arm. So, times na natog moment arm para continuous ang function. Pero take note guys, pag moment equation, ato lang na siyang butngan og 0 na exponent. Okay, anyway, any number raised to 0 is 1. Diba? Maski 1 million pa na, basta raised to 0, 1. So, ang kaning x minus 3 raised to 0, mura ra gyapon nag 1. So, walay na bag-o. 27 times 1 is still 27. So, nag-timesan lang siya moment arm para continuous ang function. Okay, I hope na gets. Kay ang ato man kung couple, wala siya nag-exist good diri as sa edge. Na siya sa between, na siya sa tunga. So, dapat timesan nato siya moment arm, but make sure lang na erase nimo sa 0 para murag wala gyapon siya effect. Okay? Ngano di ay ma'am, for example, kaning inani. Press ka ganina. Diba na ay moment diri? Tapos, diri ta nag-cut. See the right. Anong wala man ta nag-times o moment arm ani? Padulong diri sa cut. Actually, katong 240 ka ganina. Sige, balik na ko ha. Kani kaning 240, di ba na siya diri nganong wala man na siya gitimesan og moment arm na couple man pud na siya. Actually, timesan na siya. X, di ba? Unsay distance niya about sa cut? X, di ba? Unlike kung diri na siya nag-occur, so dili na siya x, x minus something, kung pilang distance diri og diri. Diri man siya sa edge nag-occur, guys. So, x lang anytime sa iya, ha. Naman siya sa edge gyud. So, yung moment arm gyud about the cut is only x. Actually, gi-raise na siya og 0. Diba? So, kung atuan ni siyang i-kuan, at atuan ni siyang integrate. So, 0 plus 1, 1 over 1. Diba? So, mura ra gyapon 240 times x. Ana na siya. Okay, so, sa kanina, example, Ang couple man gud nato, wala siya sa edge, nag-occur na siya diri sa tunga-tunga. So, mo nang naapa na siya yung moment arm na x minus 3. But lagi, buti lang yun nag-0 para murag wala lang. Kay any number raised to 0 is 1. Okay? And then copy lang ni, then copy. So, integrate na to, power formula lang. Okay? So, kabalo naman ma-integrate. So, natay C1 ug C2. Sa gani ni slope equation. Sa gani ni deflection equation. Iha ang y prime slope y kay deflection or displacement. Okay. So, get rid of C1 and C2 by applying boundary constants. So, C2 is 0 and C1 is also negative 1,237.5. Okay? So, atong final na equation for deflection EIY is ito with C1 at saka C2. C1 is 0 man, so C2 money. Ay, C2 day ang 0. C2 ang 0. So, C1 ni siya. So, kanina term is C1. Kay C2 is 0 man. Okay. So, mani ang ano ha? EIY na final na equation. Okay. So, pangutana, what is the EIY at mid-span between supports? So, when x is 4.5, na-explain na nako na anong 4.5 kaganina. So, substitute lang 4.5 sa equation. Okay, before nimo i-evaluate imong equation, look muna asa dira ang mga negative ang term. Kani positive, 4.5 minus 3 positive. 4.5 minus 6 is not positive, so 0 na siya. And this one is not positive, 0 na siya. So kanilang evaluate, and then ito, finally, the answer is EIY, negative 7087.5 Newton meter cube. So, EIY lang, kaya wala man tayo given sa EI. Okay? That's it. Next, final example. Determine the maximum deflection of the cantilever beam if WO is equal to 30 kN per meter and the length is 10 meter. So, use EI. Actually, EI ito. Kulangag I. Equal to 100,000 kilonewton square meter. So, ito yung figure, triangular load. First step, of course, we have to get the reaction. So, ang reaction ani, diri 75, tapos couple 625. Always good ng reaction. And the next step is i-cut nimo ang free end or ang far end. Kung left to right ka magtanaw, left to right, ang far end nimo is ito, right? Yan. Then, consider left. So, kung consider left na to, kani ang makita na ay shear, na ay moment. Baliktad ang shear ani ha. Typo. Ang shear is pababa. Okay, mali ang shear. Pababa always ang shear pag consider left. Okay. Karon, gikat man nato nino, wala man ta kabalo sa height sa gikat, so y na siya. So para makuha na to ang y, remember na ani na siya kaganina. So ang total height gyud sa figure kay WO nga 30. WO gyud ning total height diri na 30. So gikat nimo diri wala ka kabalo sa height, so just call it y. But ang total length diri is itong total length? L over 2, so 5. So 5 ni siya ha, gikan dira to dira 5. Nya kana pod 5. So, 30/5 is equal to y. Y ang height, and then ang kani, pila man ni, x maninggikan dira to dira. So, ang length ani is x minus 5. So, therefore, y is, ni, 6 times x minus 5. Okay na. So, pag makuha na ang y, pwede na ta mag-moment about sa cut, say clockwise positive. So, moment equation is equal to 75 times x minus 625. And then, kani, yung sa mani, triangle, 1/2 times y. And then, ang iyang length is x minus 5. Yung centroid, padulong sa cut, is 1/3 of x minus 5. So, di ba na ay y, dili pwede na naailain na variable, pero yun namang na-express in terms of x. So, pwede na nimo i-substitute. So, muna ni siya, eiy prime, double prime, equal to m. Nasubstitutan na ang y ana. So, in terms of x na natanan ha. So, integrate. Yan. Yan. So, this is the slope equation. This is the deflection equation. Then, say next step, you have to get rid of C1 and C2 by applying the boundary conditions. So, therefore, the final deflection equation is this one. Nananay C1 and C2. So, the maximum deflection is at the free end when x is 10. So, substitute lang when x is 10. Diba? Kaya ani man tong figure, oh. So, 10 man ang total dira. So, when x is 10, y max pa dira. Okay? And then, substitute EI is 100,000 kilonewton square meter. Substitute, we get the displacement at the free end equal to negative 0.189 meter. Or 189 millimeters pababa. Alright, so that's a wrap up for double integration.